A Victoria sandwich isn't just 2 cakes with jam and cream. It's a perfect model of how modern artificial intelligence actually works, transforming simple ingredients, eggs, butter, sugar, flour, into something more complex, more sophisticated, more capable, and in the case of cake, more delicious. Today, we're going to look at the beating heart of modern artificial intelligence and learn about something called a neural network, as we also bake a delicious Victoria sandwich cake. Now, modern artificial intelligence is made of 3 components. I explained this when we made Yorkshire puddings together in the last episode. Those 3 core ingredients that help modern machine learning to behave in intelligent ways are data, algorithms, and processing power. Now today, we're going to focus on the algorithm part of that, because something called a neural network is a type of algorithm that combines data and processing power to produce artificial intelligence. Now, a neural network isn't the only kind of algorithm that is used in modern machine learning artificial intelligence, but it is a particularly important sort of algorithm because it's the type of algorithm that powers things like the generative AI tools that people are using, like ChatGPT, Copilot, Gemini, and Claude. And it's also behind image recognition and many other powerful modern machine learning artificial intelligence applications. But today, we're going to look at this through the lovely Victoria sandwich, a cake, incidentally, enjoyed by Queen Victoria. She loved a slice with her afternoon tea. And we're going to build up an understanding of artificial intelligence and neural networks, one delicious layer at a time. In my mixer, I have 225 grams of softened butter and 225 grams of caster sugar. Now over here, I have 200 grams of self-raising flour, 25 grams of corn flour, and 1 teaspoon of baking powder. And in the bowl here, I have 4 beaten eggs and 1 teaspoon of vanilla essence. These are the ingredients. And just as our Victoria sandwich needs a set of ingredients, so does our modern artificial intelligence. If we think about a tool like ChatGPT, the ingredients are the instructions that we give ChatGPT. Write me an email, find me an image of a cat, whatever it is we're asking, they're the ingredients. It's what we're putting into the system. And here we're putting in these ingredients to the system of making a Victoria sandwich. As I said, a neural network is a sort of algorithm that enables us to combine the data and the processing power to get intelligent behaviours. Now you can think of a neural network as being a bit like a simplified version of the brain. It's not the same as the brain, but it is inspired by the brain. And it has lots of different layers, just like a Victoria sandwich. If I gave you a picture of a cat, you wouldn't consciously know that your brain is going through the process of saying, I can see a triangular face and there's edges here and there's 2 dots, which might be the eyes. But actually, that is what your brain is doing. It's identifying different features in the image in order to be able to recognize that it's a cat. Now that's exactly what happens with a neural network. We give it the ingredient, the picture of the cat, and then it goes through a series of processes refining the features that it's identifying until it can recognize that this is a picture of a cat. Now, we start with our ingredients. And as I say, with our Victoria sandwich, we've got butter and caster sugar in the mixer. Now I'm just going to turn the mixer on to cream the butter and the caster sugar. Now, I finished creaming the butter and the sugar, and if we take a look, we can see that a transformation has happened. It's a lovely, fluffy, creamy mix. This is the initial processing of the method of making a Victoria sandwich. And something very similar happens with our neural network. So in the same way that our creaming method transforms the butter and the sugar into a light, fluffy mix, that processing of the ingredients is what happens in the first layer of our artificial intelligence neural network. This layer is called the input layer, and it processes the information that we give it. So for example, if we're using a tool like ChatGPT or Claude and we ask it to write an email to our colleague Chris. That's the input, and the input layer of the neural network processes that information and initially breaks it down into what are called tokens, the individual words or parts of words if it's a long word, and then transforms those tokens into numerical values because the neural network works with numbers. Now, if, for example, we were using an image recognition AI system, we might show it a picture of a cat and require it to understand and recognise that this is a cat, because perhaps we want it to go and find a similar image maybe. Then we would put the image of the cat into the AI system. The AI system would translate each of the pixels in the image into a numerical value. So it processes what we give it as that input information, much as I've processed this butter and sugar to produce this lovely white fluffy mix. I'm going to start adding my eggs to the mix. I find it best to add the eggs just a little at a time, because if we add too much egg at one time, the mixture will curdle. Now, there's an analogy here too with artificial intelligence. If we try and overload it with too much input information, then it becomes overwhelmed and it won't work properly. So I'm going to get on and add the eggs to my lovely mix, a little at a time. Now, a tip that I often use when I'm adding the eggs is sometimes I add just a little bit of flour at the same time, because that can also stop the mixture from curdling. So that means that I need to sift my flour. As I say, I want to get as much air into this Victoria sandwich as I possibly can. And then I can add a spoonful of this flour as I'm adding the egg. And that will prevent the curdling that I don't want to happen. Okay, so we've now added the eggs and beaten it up so it's thoroughly mixed. And now we're going to add the flour. Now, I said we had input layers. Now, after the input layers in our neural network are what are called hidden layers. They do lots of the processing in the same way as when I was describing our brain processing an image of a cat. We're not aware that it goes through a process of starting to recognise the edges of the face and then features until it finally works out it's a cat. A similar thing happens in the hidden layers of the neural network. So that information has been processed just like our butter and our sugar, and the hidden layers then start a step at a time, a layer at a time, to refine and refine and refine until it reaches an answer. So with our example of a picture of a cat, the first layer might identify some edges and pass on information to the next layer, which starts to identify more features that it can add to those edges and passes that information on to the next layer. As I add the flour to the Victoria sandwich mixture, I have to do it very carefully, doing something called folding. So rather than beating it all, I gently fold the flour into the mix. There's an analogy here with our neural network. It works a step at a time, gently, not trying to do everything all at once. It does each step very, very quickly, but it nevertheless takes it a step at a time and processes gently, if you like. So I'm just going to finish mixing this up so that we can divide it in 2 tins for baking. I'm going to divide it into 2 cake tins. I like to prepare my cake tins with baking paper so that the cake doesn't stick. I've learnt through bad experiences that it's much better to spend the time on preparation to get a better result. It's true with artificial intelligence too. As I explained in the episode about Yorkshire puddings, preparing for the use of artificial intelligence is a key part of making it work well. In the same way that we have to prepare ingredients, we have to prepare data for AI. Now, I'm going to divide this up between these 2 tins. Then I'm going to bake it for about 25 minutes in an oven at 180 degrees centigrade. Now, of course, if you want to be precise, and precision is important, you weigh each of the tins to make sure that you do have half the mixture in each tin, so that you make sure that the layers in your Victoria sandwich are even. So I'm just going to spread this round a little, and then I'm going to get my scales and weigh them to see if I've got an even balance. I don't think I have. I think already I can see that one's got a little bit more. We'll weigh this. 725. Take the spoon out. 709. 725. 2 evenly balanced cakes that I'm going to bake in the oven at 180 degrees centigrade for about 25 minutes. Now, I'm just waiting for the cakes to come out of the oven, but what's happening while the cake's in the oven is that thousands of little transformations are happening. Bubbles expand, protein sets, sugars caramelise. It's not one change, but millions of little changes happening throughout the cake. And it's the same with our neural network. Millions of little decision units, if you like, each doing a small part of the transformation as the neural network learns and processes to reach an answer. In our example, is this picture a cat? That's the alarm. I'm going to have a look in the oven. Right, now these are still hot. They're definitely firm. I think Paul Hollywood might think they're a little overbaked. I'm going to leave these here in the tins for a few minutes to cool, then turn them out, but they'll need to cool completely before we start putting the jam and the cream on. Now you might be thinking, Rose, why do I need to understand a neural network? I just want to use AI effectively to do what I want. Well, here's the thing. If you understand the basic way in which something like a neural network works, you'll be able to be much more powerful in the way that you use AI. Let me give you an example. I was talking to a friend of mine last week who's a teacher, a history teacher, and she'd been working with a group of A-level students, helping them to write an essay about the causes of the English Civil War. She suggested that they put a prompt into the chatbot that they use, their version of ChatGPT, asking it to explain the causes of the English Civil War. They got different answers, each of them, vaguely the same, not bad, but not great. And the students said, well, I thought these tools were meant to be intelligent. Why aren't they producing better answers? The answers were mostly accurate, but just not very detailed. And the students started trying to say things like, do more analysis, give me a more sophisticated answer. I want an A-level standard answer. But they still didn't really get that A-grade A-level answer. And they wanted to understand why. They managed to get it up to almost a B. Now, if they'd understood a little bit more about what was going on, they might have realised that they needed to give a much better input in the first place than explain the causes of the English Civil War. Because what was happening was that they put in their initial request, explain the causes of the English Civil War. That was the input, that input layer in the neural network. And then that's what the neural network was working with to look for patterns in the data that it had been trained on. So it could only work with that input. And then when they started asking for extra things, it was a bit like me adding extra eggs to my mixture when I'd already got the eggs I needed in it. I'd just be making more, but not really better. And that's what was happening to them. What they needed to do was make the initial input much more detailed. If they'd put something like, analyse the economic tensions between Charles I and Parliament from 1625 to 1640, specifically considering ship money and monopolies, using evidence from primary sources like the Petition of Rights, they would have got an A-grade answer. That input is super important. And so, just like baking, the quality of the ingredients and the quality of where we start really makes a difference to the output. Now, let's have a look. So my cake has cooled. I took it out of the tins. It came out really nicely. Feels nice and soft. 2 layers here, and I've got some really lovely blackberry jam. I went out foraging in the hedgerows here, where we've got lots of lovely juicy blackberries, and came home and made some blackberry jam because I thought it would be really lovely to have with the Victoria sandwich. And then I've made some buttercream. I prefer this to cream. I've added a little bit of vanilla essence into this. So this was 60 grams of butter and 120 grams of sifted icing sugar and just a little drop of vanilla essence. So I'm going to start with the cream, but I'm going to start popping the cream on the cake. But I only want to put it in the middle layer here. I need to spread it evenly. So if you imagine these are 2 layers in our neural network, maybe 2 hidden layers. Now we need to connect them so that they can communicate with each other, so they can start refining their understanding and reach an answer. So we need to make sure that we spread the cream evenly. Because if it's too thick in one area, that'll make the connection too strong in that part of the network. And if there isn't enough cream in one part, you won't get the right connection. Now here we've got jam and cream. In the neural network, it's maths, it's a numerical connection. between the different layers in the network that helps the layers to communicate with each other, so that each layer refines the answer a bit more until it reaches the final answer. And now we're going to spread this lovely ooh, look, it's absolutely full of blackberries. I must confess, I ate a few while I was picking them, just to be honest. Now I had 858 grams of blackberries, but when I put them in the pan to make the jam, they're only 850 because I ate a couple more. And that made me 3 little jars of jam. Oh, delicious. Have a cup of tea and a piece of this cake. Look at that. Absolutely delicious. But we're going to have one little finishing touch. Well, the finishing touch. We've had input, hidden layers. Now we need the final output. We've had ingredients, we've mixed it all together, we've baked it, we've got our layers with their connection of the jam and the cream. Final touch to produce that output in the same way that those History A-level students wanted the final output of an A-level quality essay. Of course, we would want them to investigate it thoroughly, improve it, understand it, not just take it as written. When I was a girl, we used to use this trick to get a very quick and easy decoration on a Victoria sandwich. So you take a doily, you put it on top of the cake, then you sift icing sugar over the top on the cake. Make sure you do it evenly. Oh, this is quite lumpy icing sugar. And then we carefully lift, and we're left with a rather pretty pattern. And here we have the beautiful finished Victoria sandwich, the output from all of our processing. We started with butter and sugar that we creamed together. We then added eggs slowly so as not to overwhelm the mixture and cause curdling. We then gently folded in the flour and the baking powder. We baked it in the oven, and then we've constructed our Victoria sandwich, layer of cake, joined together to another layer of cake with butter and blackberry jam. And so this is just like the neural network. We have input, the ingredients, they have to be processed to form kind of input that the network can deal with. So we process the ingredients and then they are transformed just in the way that our cake was transformed by the way we mixed the ingredients together and then by the baking process. That baking process caused changes in the ingredients. Just as in our neural network, each of the little decision points in that network make decisions and your input is transformed to the output. Those students who wanted an essay put in the request, the essay comes out. The quality of the essay depends entirely on the input and of course the quality of the neural network itself. You ask one of these large language models a question, it processes your input, looks for patterns in the data that it's been trained on, how it's learnt, and then gives you an answer based on those patterns. And if you're lucky, just as with cake, you get a really good answer. That homemade blackberry jam is just the great finishing touch. A bit of tartness to the sweetness of the buttercream. And a nice soft sponge. Now, I'm not an expert baker like all those bakers in the tent on the British Bake Off, but I think this is a pretty presentable Victoria sandwich. I also hope that you found it a really nice way to start learning about neural networks. Because if you can understand how these AI systems work layer upon layer upon layer, it will help you give much better instructions to these systems and get much better output. Remember, the system starts by processing what you give it, and then it can only work on matching what you've given it to what it's already learned about. So the more you give it, the better instructions you give it, the better the output it will give you. Because if there's something not quite right in what you put in at the start, that might get transformed and magnified as it works its way through the different layers in the network. This has been Rose's AI, and this has been Victoria Sandwich. In the first episode, we looked at Yorkshire puddings and we looked at the 3 main ingredients come together to form machine learning AI: data, algorithms, and processing power. Today, we've focused on the algorithms. We've looked at a neural network, one of the most powerful ways in which machine learning AI brings data and processing power together. I'm Rose Luckin. This is Rose's AI. If you want to keep understanding AI, delicious layer upon delicious layer, subscribe and join me next time when I'll be looking at biscuits to see patterns in data, bias in data, all through the lovely gingerbread person. And in neural networks, just as Victoria sandwiches, remember, it's the layers working together that bring you the delicious end result.